Hey guys, in this video we're going to be talking about when limits fail to exist. So there are three common examples where this occurs, three reasons. So let's go through those one at a time. The first one is where we have a left-hand limit and a right-hand limit, and they do not equal each other. So this occurs pretty commonly in this example graph where we have y equals the absolute value of x over x, for example. This one is commonly used to demonstrate this occurrence. And so in this graph, if we go ahead and plot it, we would have an open circle at +1, going all the way to the right, and then at -1, going to the left. So if we were to try and take the limit as x approaches 0 of y, if we go to 0, right, so on the x-axis we're at 0, if we're looking at it from the left-hand side, going towards 0, we're approaching -1. So the left-hand limit would be -1. And if we're looking at it from the right side and we're approaching 0, then our limit is approaching +1. So we have a left-hand limit and a right-hand limit that are not equal to each other. So the limit as x approaches 0 does not exist for this function. Let's move on to number 2. So the next one is where we have a graph that oscillates really quickly at a certain point. Say f of x oscillates quickly as x approaches c. So whatever point c that we're looking at for our limit. So an example of graph for this one would be, say we have y equals sine of 1 over x. Okay, and so what that looks like graphically is we kind of have it doing this number, and then as it approaches 0, we have this oscillation up and down, and this is a very ugly version of that. But the idea is that as we approach x equals 0, we get this really rapid oscillation up and down. And if you were to graph this on, say, a graphing calculator, you'd get a much prettier image, but this does the trick. So say we wanted to take the limit as x approaches 0 of y, in this case y is our sine of 1 over x. As we approach 0, it's oscillating quickly up and down, and so we can't really get an exact measurement for what is approaching for the limit. So in this example, our limit does not exist at that point. Right, and then last but not least, if we're approaching negative or positive infinity, or in other words, f of x is increasing or decreasing without bound, so just going up or down forever, as it approaches c. So let's talk about a graph for this example. Say we have y equals 1 over x. That looks like we kind of have it approaching 0 and on the y and the x-axis in the first and the third quadrant, but never actually touching those axes, okay? And so if we were to try to take the limit as x approaches 0 of y, when y is 1 over x, then from the left-hand side, we are approaching negative infinity, and from the right-hand side, we're approaching positive infinity. So in this example, not only are we approaching infinity on either side, but one is negative and one's positive. So our left and our right-hand limits also don't exist. So in this example, we just write DNE, does not exist. But say they were both approaching positive infinity on the right and left-hand sides, in that example, we would say positive infinity. Remember, it still doesn't exist at that point, but because they're both approaching positive infinity, we can be more specific about the way that it does not exist by saying positive infinity for the answer. I hope this cleared up some examples of when you do not have a limit existing at a certain point. And just keep in mind, in all of these, I did the limit as x approaches 0 for the example graphs, but that number doesn't have to be 0. It's anywhere on the graph where these three things occur.